So in the last video, we did a proof that looked pretty similar to this, but it was in regards to linear approximations, and we said the following, that taking the linear approximation of a product of two functions is the same thing as taking the linear approximation of each of those respective functions, multiplying them together, and tossing out some higher order terms. And in this video, I want to show you that that is the case as well with quadratic approximations, and we're going to show that that is the case in general. And this here is actually a more important thing to look at than our linear approximation fact, because, I mean, when you have a product of two functions, finding the first derivative of those isn't too difficult in most cases. But in a lot of cases, when you then have to take the second derivative, which we have to do when we construct a quadratic approximation, well, those can start to become a little hairy. So if we can prove that this is the case in general, this right-hand side might be able to help us in some future problems. So again, before we begin, we're just going to get some housekeeping out of the way. So f and g are both differentiable functions. That is important to note. Differentiable functions. Okay. And again, similar to what we did with the linear approximations, we're just going to prove out both sides of these and we'll show that they're equivalent. So let's begin with this left-hand side. It just says take the quadratic approximation of the product of the two functions, and we're going to do this for an x value near some x naught. And this is going to be f of x times g of x is going to be approximately, and again, why don't you pause the video and fill in the quadratic approximation formula for this. All right, assuming that you've given it a go, let's do this. So we have f of x naught times g of x naught plus, now we have to take the derivative of these products, so we're going to use the product rule. So we have f prime of x naught times g of x naught plus f of x naught times g prime of x naught, and all of that is multiplied by x minus x naught. And just a quick note here, this is exactly what we did in the last video because this is the linear approximation. And now, since we're taking a quadratic approximation, we have to take the second derivative and multiply it by 1/2 and x minus x naught squared. So let's take the second derivative. And again, we have to use the product rule twice here. We have to use the product rule on this guy first. So we have f double prime of x naught times g of x naught. And I'm out of space, so I'm going to come down here. So we have plus, we have f prime of x naught times g prime of x naught. So that's the product rule for these first guys. And now we have to do the product rule again over here. So we have plus f prime of x naught times g prime of x naught plus f of x naught times g double prime of x naught. And all of that gets multiplied by 1/2 times x minus x naught squared. So this guy right here is the left-hand side of our equality that we're trying to prove. This is the quadratic approximation of f times g. And now, again, we're just applying the quadratic approximation formula up here. Now we're going to take the individual quadratic approximations for both f and g. We're going to look at this right-hand side now. So again, this is going to be for some x value near some x naught, and we have that f of x is going to be approximately, and again, we're just doing our quadratic approximation formula. So this is f of x naught plus f prime of x naught times x minus x naught plus f double prime of x naught over 2 times x minus x naught squared. And now we're going to do the same thing for g. So we have 4x near some x naught. Now we have g of x. It's going to be approximately g of x naught plus g prime of x naught times x minus x naught plus g double prime of x naught over 2 times x minus x naught squared. And again, this guy right here is q of f, q of g, I meant to say. It's our quadratic approximation of g. And this guy up here is q of f. And now, according to this right-hand side, we multiply them together, and then we take the quadratic approximation of that product of their quadratic approximations, which in this case just means, okay, throw out these higher order terms. So any term that when we multiply them, we end up with a higher degree than 2, we toss those out. So any cubic terms or fourth degree terms, we toss those out. So now we're going to multiply these two quadratic approximations together. So we have q of f times q of g. Okay, and this is going to be equal to, and now all we're going to do is multiply these guys together. And to save us some time and some writing space here, and to save you from hearing x naught over and over and over again, we're just going to multiply these guys up here, write out what we get down here, and anything that has a higher degree term than 2, we're just not going to write down because it's going to get tossed out anyways. So let's begin. We have f of x naught times g of x naught plus. Now we're going to go right here. So we have f of x naught times g prime of x naught times, actually, we're going to factor out an x minus x naught. We have these linear terms here. Actually, we'll save that for a step. We'll just write these all out. So we have x minus x naught. And again, this is just multiplying here to here. And then we're going to multiply here to over here. So we have plus f of x naught times g double prime of x naught over 2 times x minus x naught squared. Okay, and now we're going to go from here to here. So we have plus f prime of x naught times g prime times g, just regular g of x naught times x minus x naught times x minus x naught. Okay, and now we're going to go right here. So we have plus f prime of x naught times g prime of x naught, and then we have an x minus x naught squared left over. X minus x naught squared. And then we go right here. So we have f prime times g double prime at x naught, and then we have a cubic term. So this guy's going to get thrown out. So now we come over here and multiply this. So we are left with, and this should be our last term, we have f double prime of x naught over 2 times g of x naught. Then we have an x minus x naught squared. X minus x naught squared. And again, if we were to multiply here, you would have a cubic term. And if you were to multiply here, you would have a fourth degree term. And those would both get tossed out. So this is what we get from multiplying our two quadratic approximations together. And now what I want to do is just simplify this so we can make it look like what we have up here in orange. So that'll be our last step. All right, so home stretch, we have f of x naught times g of x naught plus. And now on these linear terms here, what I want to do is factor out an x minus x naught, okay? So we'll start here. We have plus f prime of x naught times g of x naught plus f of x naught times g prime of x naught. And again, we factored out an x minus x naught. So we have x times x minus x naught. Okay, and now for these quadratic terms here, we're going to factor out a 1/2 times x minus x naught squared. Just again, so we can get it to match with what we have up here. So we're going to factor out a 1/2 times x minus x naught squared, and we're going to be left with, I'll do these guys first, these guys right here. So we have a plus f double prime of x naught times g of x naught. And again, we're factoring out a 1/2 times x minus x naught squared. So then we have plus, and I'll grab these guys next. And again, be careful here. We're factoring out a 1/2, so we need to actually have a 2 in front here. A 2 as a coefficient. 2 times f prime of x naught times g prime of x naught. And then our last term over here, f of x naught times g prime of x naught. And again, we're factoring out a 1/2 times x minus x naught squared. So this whole thing here is going to be multiplied by 1/2 times x minus x naught squared. And what we have in blue down here is exactly what we have in orange. I don't think I can fit them both on the same screen, but they are the same. The only difference is these guys right here. These are the same two terms. You can add them together and you would get 2 f prime of x naught times g prime of x naught. And this here is exactly what we have down here for those. So again, we have just proven that this is a true equality, that we can either take the quadratic approximation of a product of two functions or take their individual quadratic approximations, multiply them together, and in this case, toss out some higher order terms when we take the quadratic approximation of those. So we saw that this is true, and again, we want to apply this in some upcoming examples, and this has a ton of x naughts in it. Don't get lost with those. This just gives us license to use this right-hand side as a method to solve some upcoming problems.